remember, is going to have questions that are similar to the one on your test. So make sure you carefully read the instructions. We'll go over those today, the things you have to watch out for, and then the certain forms that you have to put your answers in for full credit. You have to show all your steps. Remember, some are calculated, some are not. And then all of your answers must be exact and simplified unless otherwise stated. So if you have a rounded answer, the question will tell you what to round it to. And then 2, 5, 6, 8, and 11 are going to be on the calculator portion. Okay, so when we get to those, I will remind you that that's going to be on the calculator portion. Right, and then the rest is going to be no calculator. So for number 1, it says find 4 different names for the point graph. All right, so for number 1, the positive, okay, you need to count and see how many lines you have. So for this, you have 1, 2, 3, which means you're going to have 3, comma, and then another positive, and then you'll have 3 and a negative, and then you'll have negative 3 and negative 3. So if you guys wanted to do that right away, you could start like that. Now, the positive, you can see, is on 4 pi over 3. But remember, every single angle has a positive name and a negative name. So if you're on the circle and you're starting here, this is where 4 pi over 3 is, right? I can go in the positive direction to get to 4 pi over 3, or I could do what? Go in the negative direction, which would be clockwise, right? And that would be negative 2 pi over 3. So that's one way you can think of it. You can also think of it as 4 pi over 3 minus 2 pi. Okay, so 4 pi over 3 minus 2 pi becomes 6 pi over 3, which is negative 2 pi over 3. Okay, so this is something that you guys did on your treasure hunt packet, and then we also did this in 8.1. Okay, remember how you could add 2 pi or subtract 2 pi? So if you did add 2 pi to this, did you guys get 10 pi over 3? That would be another acceptable answer. Okay, so you could have that, or you could have 10 pi over 3. That would be perfectly fine. Okay, then go back to 4 pi over 3 and subtract 2 pi to get the negative 2 pi over 3. Okay, because this is the opposite, what's going to happen is you would go the opposite direction here, 1, 2, 3, and then you do the reflection, which is pi over 3. You could also find that by just doing 4 pi over 3 and subtract pi. Okay, so remember like what we did in our notes, if you had the negative, you could add or subtract pi. Okay, so if you subtract pi, you get pi over 3. Okay, and then for negative 3, just like we did here, if you want to say the negative name, if this is pi over 3 in the positive direction, you could find it in the negative direction, which would just be taking pi over 3 and subtracting 2 pi. So if you did pi over 3 minus 2 pi, you would get negative 5 pi over 3. Okay, I like to think of it as these two together would have to add to make 2 pi. So if I just ignored this negative, 4 pi over 3 plus 2 pi over 3 would be 1 full rotation. Okay, pi over 3, negative 5 pi over 3 would make 1 full rotation. Okay, any questions for me on that? All right, number 2, you can use your calculator. So you're going to convert the rectangular coordinates to polar coordinates. And then they give you r has to be greater than 0, and theta has to be between 0 and 2 pi. So this means that your calculator should be in radian mode, and that your r value is going to be positive. Okay, this says to leave r as an exact value, and then to round theta to the hundredths place. Okay, so we will be rounding on that. All right, so if you're going to convert from rectangular to polar, remember this is your x, y. So if you're given x and y and you want to find the polar is r and theta. So r squared is going to equal x squared plus y squared. So I can go ahead and solve for r. So negative 4 squared is 16. I'll actually write this out. And then negative 3 squared is 9. So r squared would be 16 plus 9, which is 25. So then when I take the square root, keep in mind r should be positive. I know my r value is going to be 5. Now to find theta, you're going to use the tangent of theta equals y over x. So your tangent of theta would be negative 3 over negative 4, which is just like positive 3/4. So then to find theta, I'm going to do my tangent inverse of 3/4. Now be careful because sometimes what you get on your calculator is not going to be what you're going to write as your answer. You have to pay attention to quadrants, and now you also have to pay attention to the fact that theta has to be between 0 and 2 pi. So I'm just going to double check my mode. I'm in radians, so I can do my inverse is 3/4. Okay, so then I get 0.64. Now, if I look back at my point, I have a negative negative, which means that it resides in quadrant 3. So I have to find this value for theta in quadrant 3 because of this point here. Okay, is 0.64 in quadrant 3? No, we should know that right away because when we think of the unit circle, we know pi is 3.14 and half of it is 1.57. So 0.64 has to be somewhere in quadrant 1. To find where it is in quadrant 3, all we have to do to that is what? Add pi, because it's always going to be directly across the circle. And that's because tangent's period is pi, so it repeats itself every pi units. So I'm just going to take 0.64 and add pi. And when I do that, I don't add 3.14, I actually add the pi. You could also do the exact value here, okay, which would get you 3.79. And it says to round to the hundredths, okay, so that 5 is going to round it up here. So remember, this is a polar coordinate, so if it's a polar coordinate, then you're going to have the hard brackets. Questions for me on number 2? Okay. 3, find the rectangular coordinates for the point whose polar coordinates are 6 pi over 3. So now we're trying to find the rectangular coordinates. If you're finding rectangular coordinates, what you're finding is x, y, and what you're given is r and theta. Okay, so what we're going to use is x equals r times the cosine of theta. This is on your formula sheet, which I showed you on Friday. Okay, it'll be here where it says other equations. You'll have to know that this is for the conversion. So if your r is 6, you have 6 cosine of pi over 3. Okay, and then the cosine at pi over 3 is it's 1/2. It is 1/2. Okay, so this is one that you're going to do without your calculator. So the cosine of pi over 3, okay, we'll know that's 1/2, and then 6 times 1/2 is going to be 3. That's your x coordinate. And then to find your y, you'll do r times the sine of theta. So 6 times the sine of pi over 3, and the sine is the root 3 over 2. So if they are on the outside of the radical, you can reduce them. 6 divided by 2 is 3, so this is going to be 3 root 3. This is a rectangular coordinate, so this is where I have the soft brackets. All right, number 4, and I will give you more room to do number 4 on your test, just so you know. You'll have some good room to do this. It says, write the standard equation of the circle in terms of x and y. And you're given that r equals 4 cosine of theta is a circle. So this is the one where we have to multiply both sides by r and then complete the square. Now it tells you it's a circle. You are going to have the general equation of the circle on your formula sheet as well, so you can use that to your advantage if you don't remember what it is. So the first thing I'm going to do is multiply both sides by r, which will give me r squared equals 4r times the cosine of theta. Now the reason why we do that is because we can substitute. What can I substitute in for r squared? X squared plus y squared. And then r cosine is going to be x. So then what I want to do is move everything to one side. So it's x squared minus 4x plus blank plus y squared equals 0 plus blank. So to fill in the blanks, remember you do half of b squared, so negative 2 squared, which is 4. And then I'm going to factor this part. So if I factor, I get x minus 2 squared plus y squared equals 4. Okay, so that's going to be my equation, x minus 2 squared plus y squared equals 4. Okay, and then it says, what is the radius of the circle? Well, remember, in the general equation of the circle, because you won't have your calculator, you can't just graph it, you have to know. So if it's r squared, if r squared is 4, what's my r going to be? My r is going to be 2. Okay, so the radius is 2 here. Okay, so r squared is 4, which means your r is 2. Okay, and then it says, what is the rectangular coordinate of the center of the circle? So remember, back from your geometry and algebra 2 honors days, that the circle center is at HK. Okay, so my H, see how it's minus? So remember it's going to be the opposite. Okay, so if you see minus 2, then your center is going to be 2 and then 0. So whatever is next to x goes first, whatever is next to y goes second. Okay, so if the minus 2 was over with the y, then it would be 0, 2 instead of 2, 0. Okay, and remember that's something that you will not have your calculator for. So you have to know how to identify that from your equation, okay, which you had done before in algebra 2 and geometry.
How would you know if you had to complete the square for both the x and the y?
You would have more than one term here, and so that won't happen for this. I won't get back to you. Okay, so because you only have the one r cosine of theta, it'll only be one variable, or you'd have r sine of theta.
Yeah, so it'd either be x or y.
Yeah.
Okay.
Yep. Exactly. Okay. Good. Other questions on your first page? You guys got everything down? In case you missed something. Uh-huh.
You didn't show us the formula sheet on Friday. Could you show it to us?
Oh, yeah, I will. I'll reference it as I go through it, and then I'll show it to you before you go. I also posted it on Google Classroom, and I posted a blank review packet for you guys, too, so you can take that like a test. All right, so I know yours does not have these grids, but you went ahead and put them on there. So you're gonna draw your graphs on the polar grids provided. And then for each graph, each one of the graphs, there's a table. And then you're gonna fill out the R value in the table. And then label the points A through E on your graph. If it is a radian, it has to be an exact value. I actually did that part for you, so you aren't gonna have to worry about that. If your R value is a decimal, then you're gonna round to the nearest tenth. And keep in mind your graph needs to be as accurate as possible. So we're gonna sketch the polar graph for R equals 4 plus 5 cosine of theta. And that's for theta is 0 to 2 pi. Remember, you can adjust that, your window, okay, when you're in polar mode, which is what we need to do first. Okay, so I'm going to go to mode, polar. If I needed to adjust my window, I would. See how this is already 0 to 2 pi? Okay, so then I'm going to go to my y equals, so I can use 4 plus 5 cosine of theta. Okay, and then I'm going to go to my table set. I'm going to start at 0. And then remember, what do I want my table to go up by? Pi over 12, because pi over 12 represents what? Pi over 12 represents each line on your graph. They go up by pi over 12. This is 1 pi over 12, 2 pi over 12, 3 pi over 12, so on and so forth. Okay, so I'm going to change this to pi over 12, if it's not already in there. I know you might use it for other classes. And then I'm going to go to my table. So remember what I told you I do to save time? I like to write what I'm going to have on each one, and then this also helps me with my scale. So really quick, I just do 9, 8.8, 8.3, 7.5, 6.5, 5.3, 4, and then I always recenter at a point that I know. So I know pi over 2 is 1.57. So 2.7, 1.5, 0.46, negative 0.33, negative 0.82, negative 1. Now, just because I'm writing all these points down does not mean I'm necessarily going to plot every single one, but it's nice to have so you can make sure that your graph is as accurate as possible. And you can see that they start to repeat themselves. Okay, so here I am at 4, 5.3, 6.5, 7.5. 8.8, and then I'm back at 9. And then if you wanted to graph it, I'm going to go to my standard. If you wanted to graph it to see what type of shape you have, you could automatically do that. This is what type of shape? What's this called? Yes, Lamazon, Lumazon. And you can tell because this is at a 9 that you're going to want to scale your graph by what? 2's. Okay, so then I'm just going to write scale by 2's. Okay, and now that I've done that, I can fill in my table pretty quickly. So my 0 is 9, pi over 12 is 8.8, pi over 3 is 6.5. At 3 pi over 4, I'm at 0.46. And then at pi, I'm at negative 1. And then I'm going to have to label those on my graph. Okay, so at 0, 2, 4, 6, 8, and 9. Here I am. Okay, and then this is 8.8, so that's actually going to be really, really close to my 9. And then I have 8.3, 7.5, which is, this is 7, this is 7.5. This is my 6. 5 is halfway in between, all the odds are half in between, so 5.3, 4, 2.7, so here's my 2, so I'm almost at 3, 1.5, so this is my 2, this is my 1, this would about be my 1.5, And then I know this is gonna be symmetric, so I can start putting my symmetric points on there too. 8.8, 8.3. This is 7, so 7.5. 7, so 6.5. Oh, I plotted that at 6. Make that 6.5. Okay, and then at pi, I'm at -1. Here, I'm at -0.82. What that's doing is that's creating my inner loop. I don't think I did this one, so that's my -1. Or -2, so -1. -0.3. 4.6, so here's 1, so that would be about half of 1. 1.5, 2.7. Oops. 2, 4. 2, 4, 5. So this would be 1.5. Okay, so then I'm going to connect these with a curve. So I'm just going to start here. Alright, and there's my Lamasom. How do yours look? Okay, so make sure that you do have the roundness. Okay, part of the points for this is built into the shape. So like if you had something that looked more like this, that was too skinny, okay, then you would have points taken off. So make sure that you do some of these outside points so that you can get the full roundness of the shape. Okay? All right, and then for number 6, we're going to do something similar. So if you go to your y equals, you have 5 times the sine of 2 theta, okay, which is going to be a rose curve. So again, I want to start at 0, go by pi over 12, and then I like to go to my table. Okay, you don't necessarily have to. You could plot them directly from here. It's just when I'm graphing, if I'm going back and forth, I find it helpful in terms of how quick I can graph it. Then of course, when you're taking a time test, your time is definitely something you want to be mindful of, which is why I recommend printing off another review just to see how your timing is. Okay, so you can take it like a practice test. If that's not something that you've been doing and you haven't been getting the grades that you want to get, that's definitely something I highly recommend. And then when you are finished, you can check it with the answers you wrote down in class today. And then the ones that you missed or didn't get completely correct, those should be the ones that you go back and watch these videos on. Which maybe some of you are doing that right now. And then remember that if you have an e, right, -1, e to the -12, that's going to round to 0. Oh, and then I am going to go back and let's put in our A, B, C, D, E. Okay, so for 5, 0, 9, that's going to be my A. Pi over 12, 8.8 is my B. Here is my C. My D is 0.46. Okay, and then my E is -1. Okay, and then I'm actually gonna plot this first, and then I'll fill in my table, and then I will label. Okay, so at 0, I'm at 0. At pi over 12, I'm at 2.5. This I can just scale by 1, so 1, 2 and a half. Remember that this 5 is going to tell you what about your rose curve? What does that 5 tell you about it? It's going to be the length of your petals. Okay, and again, all of your petals are going to be symmetric. So I'm creating this first petal here. And then here I start at 0. So if you guys want to loop around the first petal, you can do that. I know some of you like to wait until the end, and that's fine too. But again, your petals need to be symmetric. Now here I have negative 2.5. When I follow it across, I just want to make sure that I have the same denominator. So over 12 over 12. 2 pi over 3 when it comes across. 1, 2, 3, 4. And then negative 5 when it comes across. And then I know this is going to create a symmetric petal. Okay, so this is going to loop around. Oh, doesn't that look beautiful? Kind of looks like part of a butterfly. All right, and then I'm here at 0. So then I have 2.5, 1, 2 and a half. This would be 3, 4.3, 5, 4.3, and then 1, 2 and a half. And then back at 0. And then negative 2.5, which again is going to go across, so 1, 2 and a half. 4.3, which is going to come across, so this is 3, 4.3. Then I have negative 5, negative 4.3, and negative 2.5, which is over 12. Okay, so then that would round out and make my last petal. Okay, so notice how all of my petals are the same width. Okay, one of them does not look wilted compared to the other ones. So at pi over 4, I'm at 5. That's going to be my point A. At 3 pi over 4, I'm at negative 5. So this is where you have to be careful. Sometimes you look at 3 pi over 4 and you just want to put B here, but that's not correct. Your B value is here. This is where you are when you're at negative 5. At 13 pi over 12, I'm at 2.5. So that's positive, which means my C value is here. At 19 pi over 12, which is right here, I'm at negative 2.5. So I'm not just going to put my D here, I have to go all the way across. So this is where my D is. And then 11 pi over 6 is at negative 4.3. Again, that's a negative, so I have to go across. And that's where my E is. Okay, how did you guys do at labeling this one? Because this one was a little more difficult to label. So make sure if it's negative, you're going across the circle. Okay, what questions do you guys have for me?